Professor Gamble buys a lottery ticket, which requires that he pick 6 different integers from 1 through 46 inclusive. He chooses his numbers so that the sum of the base 10 logarithms of his 6 numbers is an integer. It so happens that the integers on the winning ticket have the same property. The sum of the base 10 logarithms is an integer. What is the probability that Professor Gamble holds the winner ticket? All right. So first, let's try to understand what do they mean. He has to choose a number anywhere between 1 and 46. He has to choose 6 of them. So A, B, C, D, E, and F. Those are representing the 6 numbers. And then they say that the sum of the base 10 logarithms of his 6 numbers is an integer. So if you take the log of these numbers to the base 10, the sum is going to be represented like this. Log of A plus log of B plus log of C plus log of D plus log of E, and finally plus the log of F. All of these, the sum is going to be an integer. We'll call it n. Now, I hope you know that when you have an addition question like that, you can combine them. A times B times C times D times E times F, like that. That is allowed. So therefore, 10 to the power of n is equal to A times B times C times D times E times F. This is what we have to deal with. We have to find 6 numbers that when multiplied together equal a power of 10. So let's go through this. Let's start with n equals 1. That would give us 10 is equal to A, B, C, D, E, F. And our numbers are, remember, between 1 and 46. That lottery, he has to choose numbers between 1 and 46. Is this possible? Can you find 6 numbers that are between 1 and 46 inclusive that when multiplied together equal 10? No, I don't think so. So let's try n equals 2. That means this time we have this scenario. A, B, C, D, E, F is equal to 100. Can you find 6 numbers that multiply to 100? And the answer is no. Because just to, just in case you don't believe me, the smallest numbers that you could possibly choose in this interval are 1, 2, 3, 4, 5, 6, right? The smallest 6 numbers. If you multiply these 6 numbers together, you get 720. So you can never get 10 or 100. How about n equals 3? All right, we're up to 1,000 now. Can this work? And the answer is no. You can never get 1,000 by multiplying 6 numbers together. And you can try that out, but very quickly you'll realize that it just doesn't work. So let's keep going. N equals 4. 10,000. How about 10,000? Is that going to give you anything? And at this point, the answer is yes. So how do we do that? The best thing to do is break 10,000 into its prime factors. It would be 2 to the 4 times 5 to the 4. And you have 6 numbers that when multiplied together equal 10,000. All right, let's try this out. We got 1, 2, 2, 2. I'm just putting these into its prime factors. 5, 5, 5, and 5. And this will equal A, B, C, D, E, F. All right, let's go through this. How about I'll choose this 1 here as my first digit. I'm going to make a list of 6 numbers, my winning lottery ticket. All right, choose a 2. Now what can I do? Let's see if I can go in order here. 5. And how about 2 times 10? Put these together. That gives me 10. And 5 times 5, all right, let's choose that. 5 times 5, that was okay. 25, I fell out of order, but that's okay. And then I've got this 2 times 2, which is a 4. I'll squeeze that in there. All right, I got it. I've got one possible combination. So that's great. Now, can I get any more? All right. So let's try again to get another one. And I think that's it for 10,000. So we now move on here to n equals 5. If n equals 5, we've got now 100,000 is equal to A, B, C, D, E, F. And this is now 2 to the 5 times 5 to the 5, like that. So this is going to be 2, 2, 2, 2, 2, 5, 5, 5, 5, 5, like that. So now we got to figure out a set of 6 numbers that are between 1 and 46 that multiply to get 10,000. All right. Let's do 1. Got that. How about 2? Put in a 5 in there. This 2 and this 5 I'll combine. So that gives you 10. These two 5s, 25. And the remaining digits, 5 and 8, gives you 40. Great, I got another one. Can I get any more? I think I can, because I didn't put a 4 in here. I think I could probably get a 4. So let's write this out again. 1, 2, 2, 2, 2, 2, 5, 5, 5, 5, 5. Let's see if I can get another combination. 1, I got that. 4, like there. Put a lone 5 in there. Combine a 2 and a 5. That'll give me 10. Let's see what else. 4 times 5 would give me 20. And then this 5 and 5 is 25. Great, I got another one. So I've got 2 for 10,000. I think that's it. I've exhausted 10,000. And then let's go with n equals 6. So that would mean you've got 1,000,000 is equal to A, B, C, D, E, F. And therefore, this is 1, 6, 6. Sorry. 2, 2, 2, 2, 2. 5, 5, 5, 5, 5, 5. Right? Because this is 2 to the power of 6 times 5 to the power of 6. All right. So we got to figure out another set. Okay. Got the lone 1, 5, probably get some bigger numbers. Combine a 2 with the 5, that'll give me 10. I'll combine these 2 with another 5, that will give me 4 times 5, which is 20. And then these two 5s will give me 25. And then finally, these 2s with this 5 will give me 8 times 5, which is 40. And there you go. And if you go to n equals 7, you'll find that it doesn't work. And you can do that, on your own. For the sake of time, I won't go through all this. So that means there's only 4 possibilities. We've got this one here, this one, and this one. So there's 4 possibilities, and if he has one of those 4, he wins. So 1 over 4 is the probability that he can win, and therefore the answer for number 23 is B.